Okay, if you're in my 5th grade class, you were challenged today to, well, it wasn't really a challenge, it was a review of finding factors. So we're going to find factors of numbers using the pairing method because I noticed a lot of us were missing factors along the way. So for example, let's take find factors of, I don't know, let's do like 24. Yeah, that's like a common one. Okay, so 24. All we do is we start off with 1 in itself, because 1 in itself are always going to be factors of this number. So you list the pairs, and the way I recommended for you guys to do so you don't miss any factors is to start with the smaller number, which is 1, and then to increase it by 1 every time. And then you just check if those divide 24 and come up with factor pairs. And so the next one after 1 is 2. Well, 24 is even, so 2 is going to divide 24. So let's go ahead and figure that out. So 2 times what gives me 24. If you need to do long division, go ahead. No problem with that. But if you remember from class today, 2 times 12 gives us 24. Now I just move on to the next factor. Well, I checked 1, I checked 2, let's check 3. Does 3 divide 24? Sure, because 3 times 8, since you worked on multiplication tables really well on 3rd and 4th grade, you should know that. So 3 times 8 gives me 24. I checked 1, I checked 2, I checked 3, I move on to the next one, which is 4. So then now I check 4, and I go, does 4 divide 24? Of course it does. 4 times 6 gives me 24. So I list all these factor pairs, and what I told you in class today was the moment the factor pair numbers are like 2 apart, or it's like one thing times itself, or like 1 apart, you can stop. The good thing about this method is that when you start from 1 and you just keep going up the chain, you're not going to miss any factors, because the moment you get to, like I said, factor pairs that are really close to each other, you're done checking. You don't need to check. Well, if you really want to check 5, you can check 5, and you see that 5 doesn't divide this number. 24 is not a multiple of 5. So then 6, we've already checked that off. Well, the cool thing about this method, like I said, is you don't have to check 7, you don't have to check 9, you don't have to check 11, you don't have to check 12. Oh, well, I mean 12's there. You don't have to check 11. So you're already pretty much done. This is one of those methods that are going to help you to not miss factors along the way. So now, since they usually want us to list factors in a numeric order, I use what I call the racetrack method. Start with 1, go right around the racetrack, and I just list them out. So let's do that. It starts with 1, I've got a 2, 3, 4, 6, then I just keep going up, 8, 12, 24, 6, 8, 12, 24, and those are my factors of 24. Let's try another example. So now let's check a bigger number like 60. 60 is one of those infamous numbers that have a lot of factors. So let's start with our method. We start with 1 and itself, because we know 1 and itself are always going to be factors of 60. Bam. Okay, now we check the next one up from the smaller side, which is 2. So 2, does it divide 60? Yes, because 60 is an even number. So if you really wanted to use long division, no shame, you could do that. But from class, you know that 2 times 30 gives us 60. Well, keep going up the numbers on the smaller side. I checked 1, I checked 2, next one is 3. And today's class, we discovered that, yes, 3 does divide 60. 3 times 2 is 6. Well, add a 0 to that, we've got 60. 1, 2, 3, let's check 4. Does 4 divide this number? Yes, it does. This one, right, we did long division to check. 4 divides 60. 4 times 15 was 60. So we know that works. Well, the next one I check is 5. All right, well, the number ends in a 0. If a number ends in a 0 or 5, remember our divisibility discussion, we know that 5 can divide 60. 5 times, 12 is 60. Well, okay, next one, 6. 6 divides 60. Super cool. Okay, 6 times 10, right? Multiplying by 10 just adds like that 0 at the end of the number. So 6, 0. All right, 7, we checked that in class, didn't work. 8 didn't work. 9 didn't work. There's a trick for 9s. There's also a trick for 3s that are very similar. We'll talk about that in another video for the visibility. So 7, 8, 9, none of those are going to work. Well, we already checked all the numbers between 6 and 10. We're done. We don't need to check 11. We don't need to check 13, 14, none of that stuff up above on this side. That's the cool thing about this method. You're pretty much fail-proof in not missing a factor until we get to some bigger numbers. Maybe we'll do an example of that later on. Okay, so here's the racetrack method. Just start at 1, vroom, vroom, go right around, and we'll list these in numeric order. The cool thing about this method, it's already in numeric order. So we go 1, we got 2, we got 3, we got 4, we got 5, we got 6, then we just go wrap around and go up. I got 10, that's a lot, 12, got a 15, 20, 30, 60. I'm just gonna go down here. 20, it's not a 26. 30, oh my gosh, 60. Cool, check, done. So that's my long list of factors for 60. So, okay, so in class, we were tasked as a group, as a class, to check 124 and its factors. Some of the guesses we had were, well, it's like way bigger than 60. Is it gonna have a lot more factors? Well, let's check. So in class, you guys started out with, well, okay, 1 and itself. 1 in itself, always factors. Awesome, check. Okay, now we move on to the next number on the smaller side, 2. Okay, well, it's an even number. 2's got to divide it. So we discovered that it's 2 times 62. Cool, check. Does 3 divide this thing? The trick here is, well, I mean, long division tells you it doesn't. But if you add up the numbers here, 1 plus 2 plus 4, that is not a multiple of 3. 3 is not going to divide it. Like I said, I'll do another video on divisibility later on. Okay, so 3 is not going to work. Well, does 4 work? Yes, it does. And we discovered that in class. 4 turned out 4 times. If you do long division, you can check this. 31 is also a factor pair of 124. Okay, then you guys got a little stumped. We kept going to 5, 6, 7, 8, 9, 10, 11. None of those worked. And then you guys started checking like bigger 2-digit numbers like 16 and like what about 18 and blah. And then it got a little tricky. Here's a hint. If you get stuck with this method and you're checking bigger numbers between 4 and 31 and you're getting a little stuck, there's a trick that you can do. Remember prime factorization? So you can actually prime factorize this thing, right? And since, again, it's an even number, I'm going to divide by 2, right? Well, I got 2, 2, and then, again, I know 2 and 62 make up this number, so I'm just going to go 2 times 62. Awesome. Okay, well, when I prime factorize this side, because 2 is a prime, so we're done with that side, I have 2 times 31. Well, we know 2 is a prime. Now, here's the thing. We know 31 is a prime. Well, if you didn't, now you know. If it doesn't come up in your multiplication table, it's a prime, okay? So we got this 31. Well, we're done. That kind of covers all the numbers that are here. Well, 1 times 24, we know that's a given. 2 times 62, that's covered here. Let's look over here. Our prime factorization tree stopped right when we hit this point. Well, that's this factor pair we have here. It's these 2 2's, because these are all just factors. 2 times 2 gives me a 4. Here's the 31. Well, that's this pair. There's nothing else. The prime factorization can help us to see that. This is one of the powers of prime factorization. I'll talk a lot more about prime factorization on this channel in the coming few videos. Okay, so now we just use that racetrack method. Go around the racetrack, list all the factors in order. So here we go. We got 1, we've got a 2, we got a 4. On the bigger side, we got a 31, we got a 62, we got a 124. We are done. This is pretty interesting because in the class discussion, remember, we thought, well, 124 is a much bigger number than 60, so we thought we were going to get a lot more factors. Sometimes A lot of times, that's not the case. Bigger numbers aren't going to always necessarily give you more factors. Awesome discovery. Thank you so much. Bye. Making a video. Can you wait? Thank you. Thank you, Tux. Okay, so in